Assalamu alaikum, dear students. Starting from today, we're going to talk about the sequential logic. Uh, During the last chapters, we discussed the combinational logic, and we said that what is combinational logic? The combinational logic is the combination of logic gates, right? So we create a logic circuit, which produce the certain output based on the given input. So for each input, you have the one output. And today, we're going to start talking about the sequential logic. And we see some of the examples like the latches, flip-flops, and timers, right? So as you can see here above on the title. But first, let's talk about what is the difference between the sequential logic and the combination logic. In case of the sequential logic, the logic circuit, the output depends not only at the input, but also at the past values of the input. Okay, so it depends on the sequence of the inputs. So the output does not change immediately. So with the combination logic, as soon as you change the input, the output will be changed. But with sequential logic, it may not be like that. Okay, so depending on what kind of input you have, the output also depends on the previous input as well, the previous input. So today we're going to see some of the examples. And this is the contents for today. So at the beginning we start talking about the latches, and then we move towards the flip-flops, the applications, one-shot, etc. Okay. And the objective for this chapter is to understand the fundamentals of the sequential logic, use the logic gates to build the basic latches, understand the difference between the latch and the flip-flop, explain the different types of the flip-flop, and apply the flip-flop in a basic operations. Okay, so later for your final year project, you can actually use these latches or the flip-flops that we're going to cover today for your project. So the first thing that we're going to cover for today is called a latch. So latch is a type of a temporary storage that has two stable states. So here you can see the example. This is actually the logic circuit, this circuit for the latch, right? So this one is called the SR latch. Why? It has two inputs, set and reset. S means for the set, R means the reset. Now if you look here, we have the two inputs, but the output of the first OR gate is connected again as a second input for the second OR gate, right? So if you look here, so there's a connection here, right? So let me use my pen, right? So as you can see, this output is connected as an input to the first NOR gate, and same is happening here, right? Now, what does it mean? So first, let's look at how it operates, right? So let's look at the operation of this SR latch. Okay, so I created a circuit in a circuit verse. So let's go look at here. So this is the latch, and this is the inside, how it looks like, the same circuit that I created right now. Okay, so this is the circuit. Now, how it works? So if I want to set, for example, if I want to store the certain digit, I want to store the binary 0 or binary 1. So what I will do is I will send for example, I send a high signal through the set. So this is the S equal to 1, right? R is 0 in this case. Now as you can see, the output Q is 0 and the Q complement is equal to 1. So right now, pay attention here that this 0 here. So this is the binary value that I am trying to store inside the memory. Okay, so now inside the memory I am storing this number. This is the 0. This is the number that I want to keep inside the memory. Okay, now look what will happen if I change the input now. So this input S, it was actually it's still 1, right? If I change it to 0, if you look, if I change it to 0, the output is not changing now, right? So let's say that I cut the power. Now you can see the output is not changing here, right? So output is still 0, right? So this is what the sequential logic means. With the combination logic, whenever you change the input, output is changed as well. But with sequential logic, as you can see here, now when I change the input, output is not changing anymore. So now I have this value stored inside this latch, right? So this latch now constantly producing the 0 in this output and 1 at this output. Now let's say if I want to store the 1, so binary 1, so the Q I want to make it equal to 1. All I have to do, I send the high signal through the reset, so reset will be equal to 1, and set I'll make it equal to 0. Now if you look here, the Q is equal to 1. So now this latch is holding the binary 1, high signal. So if I, for example, again cut the power, so if I change the R to 0, as you can see, the output is not changing anymore, right? So this is how the latch operates. So as you can see, when I change for example, these two, both of them are 0, 0, nothing happens, right? The output is not changing. Okay, so again, if I want to store instead of the 1, if I want to store the 0, I change S to be equal to 1. Now Q is 0, right? If I want to change it to the 1, I send the high signal through the R input, and now I have the value of the 1. So now I can store this data inside the latch. So I have the binary 1 inside the latch. Okay, now let's go back to our slides. Right, so this is how it works. Now in this case, the input and output is bit not correlated, right? So I'm sending the high through the S, but the output is 0. So how to make the input and output to match? So I want to save the 1 when I send the 1 through the S input, and I want the Q also to be equal to 1. Very simple. I just have to do the active low input. So meaning I have to just go through the inverter procedure here. So I can do, what I do is just I add here at this step I add the one NOT gate, right? So now what will happen is that whenever I send the high signal through the S input, so this is the input S now, right? If I send 1, the latch holds the value of the 1, right? So you can see here, so this is 1. If I change it back to 0, right, and I change this one to the 1, now when I send the 0 through the input S, the Q is also 0. So Q is the value that you want to hold inside the latch. Okay, so again, if I change it back to 1, output will be 1. So this is the Q is the value that we want to keep inside the memory, right? And this is the value that we are sending as an input. So if I change it back to 0, as you can see, the output is not changing anymore. So this latch is holding the binary value. Okay, so we have the two types of the SR latch. This is active high, this is active low. Only difference is that we have the extra, the NOT gates at the input, right? So these are the input. So to make sure that the input and output will match, right? So when you want to store or set the latch to be equal to 1, it will be actually equal to 1. Okay. So let's move to the next slide. So this is just how you can implement it using the negative or the NAND gates. Okay. And this is just the explanation that we did just now. So this is if you want to, we already did this using the circuit verse. Actually, this circuit verse, I like this tool very much. The last year, the previous years, I didn't have this tool, so it was very difficult to explain how it works. But right now, I think it's very simple, right? So for example, I have the input S here, and I want to store the value 1 inside the latch. All I have to do, I just send the 1 through this input, and I can see the output is 1 now. So if I change it back to 0, output also still will be 1. So now the latch, as you can see, holding the value of the binary 1, and it's very easy to explain when you can see this visually. If I want to send for example, the 0 here, all I have to send, I send the high signal through the reset. So I change the S to be 0 and R to be 1. So now as you can see, the Q is equal to 0 now. So this latch is holding the value of the binary 0. Okay, but before, before I had this circuit verse, I have to do this explanation using these slides. But now it's much more easier. Okay, so this is a truth table for this latch. So when you send for example, the 1, so this is active low, right? So when you send the 1, the Q is 0, the latch is reset, and when you send the 0 through the S, the value is 0, etc. So you can see how you set and reset the latch. So set means you store the 1, reset means you store the 0 inside the latch, etc. And when both inputs are 1, 1, nothing is changing. So this is in our case, for example, in our case it's different. In our case it's 0, 0, right? So what happened is that when I move for example, if I change the 0, 0 here, as you can see, the output is not changing. Okay, so if I, for example, let's now set the 0 here. Let's keep this value. If I change it 0, 0, output is not changing. So this is the state, the no change state here. Okay. And this is invalid state. Why it's invalid? Because if I change it to the 1, 1, if I change it 1, 1, as you can see, both outputs are producing the 1, and this is not correct. Okay, because the output should be the Q and Q complement. So if the Q is 1, the Q complement must be 0. But now both outputs are equal to 1. So that means that this latch is in an invalid state. Okay, so this is an invalid condition. So the valid case, the output should be the in opposite, right? So 1 and 0 or 0 and 1. Okay, so this is how it looks like from the outside. So this is how it looks like here. I already created this. I will give the link to this circuit so you can see it and you can, the play around. Okay, and now this is just the relation between the input and output for the digital waveform input. So in this case, for example, this is the S, and this is R, and this is the Q. So you can just guess this by looking at the truth table, the truth table here. Okay, or you can experiment by sending the sequence, binary sequence, and I actually did that. So later we're gonna see this. For example, it should be here. Yeah. So you can see that this is I'm sending the different inputs and seeing how the output is related to the input. So if I change, for example, the 1, so you can see the output is changing. If I change it to the 0, the output is changing, etc. Again, I will explain this later. Okay, so but you have to be able to see the correlation between the input waveform and then the output waveform, and also you have to be able to read these digital waveforms. Okay, so how you're gonna read? You just look at this clock cycle. For example, the S is 0, right? R is 1. So this is in a reset state. The Q is equal to 1 according to this truth table, right? S is 0, R is 1, the Q is 1 here, and etc. Okay, so you can just follow this. Diagram. Next, you can actually connect the multiple latches to create a bigger and bigger storage. So right now, this latch here, so this latch that we created right now, it holds the only single bit. But you can connect them. For example, here they connect the 1, 2, 3, 4 latches. So now this is actually the quad SR latch. So this latch here, it can hold 4-bit information, just right. So up to the 4 bits of the information by just connecting the 4 latches one after another.